So I sent you guys an email, and then I don't know if I sent a follow-up email. Can't remember. Sent so many different emails to different groups, and you guys are actually the ones that I messaged first. Oh yeah, and then I was like, because they were like, don't contact your students. I'm like, okay, but I already did though. So, because I need to let them know that I'm moving their test. And so luckily there was, just follow what we're doing until you get an email from me saying we do not have class on Friday. We will have our test on Friday. Right? So just so we're clear on that, because I know there's a lot of stuff going on. Business, for example, sent out an email saying the whole campus is closed from Tuesday. That's not actually true, but anyways, we're all just doing our best. So that gets confusing, right? And so anywho, here we go. So until or unless, I'll say, because that maybe that's better. Unless you get an email from me saying we don't have class on Friday, test number 2 is still on Friday. So we need to prepare for that today, right? So you got a couple of things, right? And just to clarify, now I don't have any copies, but the one that says formula slash worksheet, that's the one that I'll give you on the side for the test, right? So you don't need to have those on your cheat sheet. But like you probably saw, right, you're allowed to bring in one page that I gave you, a blank one, with whatever you want on it, front and back. Use the whole thing. I know, sorry. Now think of how much you can put on the back. So front and back, whatever you want on there, be it, solutions, fully worked out problems, your essay from English class, I don't really care. Whatever you want on here, you can have for the test, right? Pictures of your cat, I don't care. So whatever you want on there, put it on there. That's your cheat sheet. Okay? You also got one that looks like this. This one you won't get, but it has some gibberish on the back, except the unit circle is really nice, right? And so it has some useful formulas on here that aren't on the formula sheet that I give you. So you might want to steal those and put those on your cheat sheet, right? So this is just to help you make your cheat sheet a little bit better. So for the test, you are allowed one double-sided cheat sheet.
Will the test be a little short answer again?
Well, I'd say most of these are pretty well just short answer, except for if you look at if you look at questions on the practice test from sections 3.1 and 3.6, right? Those have multiple parts. So those ones are going to take a little bit longer probably. So I would call those long answers. The one from section 3.3 involves long division of a polynomial, right? So maybe that's a kind of a long answer too. The rest of them are on the shorter side, probably.
And will there be questions from this practice test?
They'll be exactly from there. Yeah. I repeat, the questions on the test, just like test 1, we're not changing anything. They will be from the practice test. Okay? You've got the solutions. I posted the solutions on Moodle. Let's see what happens. Okay. I want this to be a good test for you guys. I want these grades to be crazy high. Okay. Because then we can kind of say, okay, well, we've tested all this material, so we're safe, right? We don't need to worry so much about setting up, testing and whatever. We'll maybe just do little quizzes or something instead, right? So it frees us up for the rest of the term. So I know it's brutal this week, but it does free us up for the rest of the term for a little bit. So it's good. For the final exam, I know we don't know what's going to happen. I heard that they're meeting today to kind of figure out, kind of nail down a plan, what it is. So until I know, we don't know. If we don't have a face-to-face final, then what we'll do is we'll adjust the grades and just kind of, we could have an online final. I would push for no final just because we've tested all this material, right? And so don't get too excited about that. There's a lot of other instructors. But so those are just things that we're discussing and trying to figure out. So that's why we need to have this test, so that's an option. Write notes to each other, not so chatty. You can write notes to each other or text each other, something silent. All right, so for the test, you're allowed one double-sided cheat sheet, and you will be given the formula / worksheet is what it says up at the top. So you'll have that additionally. All right, things are gonna get weird today. What we're gonna do is we're just gonna work through how to do the problems on the practice test, and then just introduce concepts that we need as we go. That's weird, right? But next week we can fill in the gaps and we can kind of talk about why that is. But for now, we'll just learn how to do these problems, and then we'll move on. All right, so I'm not going to be able to spend any time, unless we have time after, on the first couple of sections. But we did get to spend quite a bit of time in chapter 4, so that was nice. Let's see here. So here, this is from practice test number 2, and this is from section 5.2/6.2. Oops. That's weird. Insert last image. It's a screenshot. Okay. So you've got these guys. I guess you've got them in front of you, so we don't need to make them. So what it says, and I realized later that it could be a little bit confusing. So one of each of the following, see how there's 3 different question types in that section? So there's going to be one from each of those. Okay? And so let's start with the first one. So it's going to be one of these. So I think we should start with, well, why change what we've been doing so far? How about we just do 10, right? Kind of work our way backwards. Okay. Although these ones don't really vary in difficulty. Once you've got the pattern, then you're going to be okay, right? And so let's do 10A. we want the sine of 3 pi over 4. We didn't really get that far last day, right? But I'm going to show you how we're going to do these. Okay? First thing we need to do, and this we did talk about, is figure out where this angle is. Okay, so our angle is 3 pi over 4. So I'll make little notes as we go here, but our angle is 3 pi over 4. Do you guys remember SOHCAHTOA? Right? Sine is opposite over hypotenuse, cos is adjacent over the hypotenuse. Right, so SOHCAHTOA, we're going to be using a lot of that here. So, all right. So 3 pi over 4 is our angle. So what we want to do is we want to figure out where this angle would be on our unit circle. Right? And so what we do is, well, I know that, for example, going all the way here, well, going all the way around is 2 pi. So this must be just pi. If I break that up into quarters, right, then at this point, I've gone 3 pi over 4. Okay. So the key for these is just to figure out, okay, well, if that's 3 pi over 4, then remember we talked about terminal sides, right? So here's the terminal side. And then we got this, we talked about the reference angle. And I know I'm speeding ahead because we have to. But so this is called the reference angle, right? It's the angle from the terminal side that's closest to whatever x-axis is closest, right? And so here we've got this reference angle, which must be pi over 4. So what we can say is we can say that the reference angle is pi over 4. Okay. This is where well, we've got a lot of different options here. Oh, you know what? I just noticed the setup on this. Okay. Do you want to just use the circle? Will you guys all put the circle on your cheat sheet? Because then we can just use a circle, right? We can use the reference angles, or use the circle. So that's, oh shoot. Oh, I've got a different, here, I can find it, hang on. Here. Oops. Let's get that bad boy in. Oh, keep doing that. There. Okay. So, all right. Now, I know it's blurry on there, but if you flip to this circle, right, if we want 3 pi over 4, right, so what we do is we find our angle, right, then the point is at negative root 2 over 2 and root 2 over 2. And so what we need to remember is that the x value is going to be the sine. Now I'm doubting myself. Hello? Weird. Okay. I was just moving. Anyways, let me see here. Let me just see here, just to make sure what the sign. I'm pretty sure. Oh, we can do this. Oh, shoot. My only goal was to not confuse you guys, so that's why it's like, that is all I want to do. And now I can't remember this very basic thing. Oh, okay. Here it is. In all of these, right? So all of these little guys along the edge, right? They're in the form x comma y, of course, right? Where x is the cosine of theta. Theta is just the angle, right? And y is the sine of the angle. Okay. So in our case, right, we've got cos of 3 pi over 4 would be negative root 2 over 2. And then the sine of 3 pi over 4. So therefore, the sine of 3 pi over 4 is going to be root 2 over 2. We've got papers everywhere. It's crazy.
Where do you take root 5 over 2? Where it's come from?
The root 2 over 2.
Yeah.
So it's on your formula sheet here, right? And so, or not on your formula sheet. This is the one that you have to copy. It's on the back page of that trig handout, right? So here's 3 pi over 4, and so it maps to negative root 2 over 2. But that's cos, so here's the sine of it. Right? So if we look at, so if we use this circle, right, then what's the next one here? Sine of 5 pi over 4. If we find 5 pi over 4 on here, right, I'm down here, so I'm at negative, negative root 2 over 2 and negative root 2 over 2, right? And so, so the sine is negative root 2 over 2, same with the cos.
On the outer side there is a cos, on the inner side there is a sine.
So here, how to read those, right? They're in the format x, y. X is the cos and y is the sine. Good. Okay, so because all these are going to be over 4, so they're going to be kind of root 2 over 2, kind of boring. Let's do 8a instead. 8a is the cosine of 19 pi over 6. Cosine of 19 pi over 6. Okay. Here's the problem, right? 19 pi over 6 is going to be, you're going to be going around and around and around, but then we have to figure out which one do we end back up at, right? And so usually what I just do is I just kind of cheat and say, well, if I'm at 19 divided by 6, then I've gone 3 revolutions around, and then my calculator tells me I'm 1/6 the way, right? But what we can do here is we can say that this is the cosine of 3 times 1/6 pi, right? Might be good to recognize, so to be able to recognize that 1/6 is 0.1666, depending on how your calculator works, right? My calculator gives me the exact answer, so that's nice. But if yours just gives you decimals, right, then be able to recognize 1/3, 1/4, and 1/6, because those are going to be the ones that we go for. Okay. And so here, right, at the end of the day, we'll have gone 3 revolutions around and then 1/6 or pi/6. Right? And so what this looks like here is, oh, what a bad circle. We'll have gone 1, 2, 3. Oh, no. 1, 2, 3 pi/6. I had to stop so I didn't change what I was doing. Right, because here, this distance is pi/6. Okay. So then to translate that to the circle, right, now I'm at pi/6 and I want the cosine of that. So that's going to be the same thing as √3/2. Should be positive because we're in the first quadrant. Close 19 pi.
So we're splitting the circle up into 6 sections, and then we go 3 times 6. What's left over is the...
Yes. Except I think I forgot that the circle has 2 pi, not 1 pi. That's why, okay, I have to redraw my circle anyways. Sorry, guys. Like I said, my one goal was to not confuse you, and here we are. I'm confusing you. I'll erase this for now. 3 pi, not 3 times 2 pi. So the 3 goes 1, 2, oops. 1, maybe I'll use different colors. 2, 3, and then green, I guess. Pi/6. Which is going to be this one here. That's 7 pi/6. Because it's in that same position. Notice, I know this circle looks bad, right? But notice that each of, so if you break it up into the quadrants, right? Notice that each of the quadrants only has an over 6, an over 4, and an over 3, right? So if your question has an over 3, right, then these over 3s are your only kind of options, right? Just ignore the rest. So for us, the reason that I can say quickly that it should be this value, right, is because that's the only one that's over 6. Right? This one's over 4, this one's over 3. Right? So it must be this one that I'm going for.
So how do you know that it's in that quadrant and not the next one?
So, well, I messed you up, that's why. That's why it's not too clear. Hang on. Now, oops. go like this. Because what I did, right, was I took 19/6 on my calculator to see how many pi's I could get out of there. What I messed up on initially was thinking that a circle had just a pi going around, but it has 2 pi, right? And so pi is just half a distance, right, or half a circle. And so what I'm saying is that if I can rewrite 19/6 as 3 times 1/6, right, then I've got 1, 2, 3, and then just the last pi/6, putting me in this quadrant here. So then the cosine is the x value on our graph, and so it must be -√3/2. Yeah. Let's do another one. Let's do the 8b. (8b) was the cosine of -7 pi/6. Nice. Cosine of -7 pi/6. So if we draw this out, negative angles, remember, go in the clockwise direction, right? So now I'm going -7 pi/6, which means I'm just going, so if I look at 7/6, right, then I'm going 1 pi. So I'm going from here, right, that would be -pi. And then I'm going to this point here, another -pi/6. Because if you do 7/6 on your calculator, I get 1 1/6. So here, this point on your circle is going to be the same as the angle for 5 pi/6, right? Because we're over 6, and so those are the ones that we're focusing on. And so, and we wanted the sine or cosine, I can't remember. The cosine, which is -√3/2. Again. Oops.
Okay, so the whole number of how many pi's, because 180 degrees is 1 pi, then you go to half, and you have the remaining 6. So
That's right. Yeah.
So the 19 divided by 6 was 3.
That's right. Okay. Awesome. Good. It doesn't help that I was thinking 1 revolution was just pi when it's actually 2 pi. That's the key. Yeah, so you want to figure out kind of, well, which direction it's going. Take out however many revolutions you've got, right? And just figure out where you're landing, the angle is landing. What's another one? Let's do 6b just for some variety. 6b, cosine of 11 pi/3. Cos of 11 pi/3. So 11 divided by 3. I'm at the cosine of, and I'm just going to write 3 times 2 over 3 pi. Right? That's a little bit weird. Okay. But if we think about our circle here where we're landing, so we're going in the positive direction, and I'm going 1, 2, 3, and then 2/3 of the way. Right? So, and then 2/3 of the way puts me at, that's right. And then here, this is 2 pi over 3. Oops. And this distance, or I wish I had this one better, but so now, right, I'm at 4 pi over 3, again, just because it's over 3, so I'm gonna go for, as long as I land on which quadrant I need to be in, right, so if I know I'm in this 3rd quadrant, then 2 pi over 3 is that distance, but that's not, you know, ultra helpful on our graph. Or if you want to, you could say, okay, well, I've got 3 pi over 3 plus 2 pi over 3 puts me at, no, scratch that. Anyways, this is where I want to be. So the cosine of that, is that the one we want? The cosine of that, I'll put it down here.
And the 2/3 is the 2/3 of the next quadrant. So you go into the adjacent quadrant.
No, you would stick here on the circle, right?
So the line that you stop at, the pi that you stop at, you go
Let's put
the
it down
remaining
here.
fraction into the next quadrant.
Yes.
Okay.
So you go until you've done a complete half a revolution.
Yeah.
And then whatever's extra, that's where you kind of go to.
Okay.
So then here.
But how would you know it wasn't in the next quadrant over?
Like this one here?
Yeah.
Because we decided that 11 over 3 is 1, 2, 3, right?
Yeah.
So that puts you there. And then in order to get into this quadrant, right, 2/3 pi.
Because would it not be 2/3 of pi, which would be in the...
I think he might be right. You're totally right. Okay.
I thought the vertical one on the bottom was 3 pi over 2, right? Which isn't greater than 2 pi over 3. No, which is greater than 2 pi.
The 2/3, because we're going...
We're saying this is 2 pi over 3, but 2 pi over 3, well, 2 over 3
Because isn't it 2...
is more than a half.
Yeah.
Yeah, it's more than a half. So you're totally right. We should be going down here. This is 2 pi over 3. Scratch this. And let's steal the other one instead. scratch this. And I'll just change this to pi over 3, and then that's 2 pi over 3. That's confusing though. How about I just delete this? Which is at 1/2 negative root 3 over 2. Depending on your calculator, it might just give you the answer. Yeah. So, just kind of depends. All right. I flipped those. Anyways, let's move on to the other one. Okay. Okay. This one I did work through. So no excuses for this one. Oh, lights come on and everything. Wow. So we're gonna make a trig substitution. It is gonna use your formula sheet, which you do have. So we will use some of these trig identities on the second page, right? And so we'll kind of keep an eye out for these. We're not going to talk too much about them, but we'll use them as they come up. Remember, it's just going to be one of these three. So as long as we're able to do one or potentially all three of these, then we're okay. So for example, 1a, we've got 4 minus x squared. And we want to substitute x equals 2 cos theta. So what I'm going to do is I'm just going to plug in, wherever I see an x, I'm going to plug in 2 cos theta. So I've got root 4 minus, and then all in brackets, 2 cos theta. And then squared. So now, what I'm going to do, because I'm multiplying the 2 and the cos theta, I can bring in that square, right? I can square that. And so I get the square root of 4 minus 2 squared times cos squared theta. Just as a side note, because I know we haven't talked about it, but cos squared theta is the same as cos theta squared. So it doesn't matter which way you write it. Okay, so what I've got here is I've got root 4 minus 4 cos squared theta. We usually just put the square on the cos because otherwise it gets confusing. Are we squaring theta? That might happen, right? Or are we squaring the whole thing? Right, so just to make it clear, we put it on the cos. So now, if I want to simplify this thing, because that's what we want to do, I can pull out a common 4, right? There's a multiple of 4 in there. And so what I've got is I've got 4 times 1 minus cos squared theta. Okay. 1 minus cos squared theta, this is where so at this stage in the game, in all of these questions, this is where we're going to look for a trig identity, just to replace 1 minus cos squared with one thing squared. And so what we've got is, and this one's a good one to just remember, sine squared, we've got x on the formula sheet, but we're using theta. Sine squared x plus cos squared x is 1. So then 1 minus cos squared x must be sine squared x. So what we're doing is called a trig substitution, right? We're substituting in these just replacements using the trig identities. So what we've got here is 4 times, and replacing that with sine squared theta. I'm only allowed to break up the square root as only if I'm multiplying inside, right? So that's why I had to get one thing that I'm multiplying by. And so now I'm allowed to do root 4 times the square root of sine squared theta. But same thing as before with the cosine, the square is just behaving like a regular square. And so we get 2 sine theta, and then we're done. Okay. Like I said, I did go through these ones. The other ones, I was like, oh yeah, that's fine. Bad idea. Bad idea. But I do think with the circle, you can figure it out. And if we have more time, we'll go back and do them. But all right, let's do part B. Root 25 plus x squared. Root 25 plus x squared. And we're replacing x with 5 cotangent theta. X is 5 cotangent theta. I know we haven't talked about a lot of these, right? Cotangent, whatever. But I'm just showing you how to do these so that you can recreate it on the test, and then we can fill in the gaps. So here, this is going to be 25 plus 5 times cotangent theta squared, which is 25 plus 5 squared cotangent squared theta. Which is 25 plus 25 cotangent squared theta. Wait. So now we can pull out a common 25 and get 25 times 1 plus cotangent squared theta. So again, this is where we go to our formula sheet. And we look for something that involves cotangent squared, and they're usually going to be in the first row there, right? And so 1 plus cotangent squared theta is the cosecant squared theta. So again, right, we're able to replace 1 plus cotangent squared with just the cosecant squared, right? Making that substitution. And so what we do is we go root 25 times cosecant squared theta. And same idea as before. Now that I'm only multiplying things in here, then I can split up my square root on top. And so I get root 25 times the root of cosecant squared theta, 5 cosecant squared, or sorry, cosecant theta. Do you want to try C on your own? Let's do it. I'll copy it down though. Yay. Is that what you guys got? Nice. Nice work, guys. Just going in blind, doing it. That's awesome. Well, it's not awesome. Well, I'm impressed is what I want to say. Not that fun to go in blind, but weird. Okay, so there's one of those three, but we saw all of them now together, right? So hopefully those ones are okay. And then same deal here. This one is on here. So these ones that we kind of typed up separately, example 1 and example 2, we did those because those are also on the final exam. So at least now we'll have covered a lot. So solve the following equations for x. Make sure to give, and then we changed it. We made it a little bit easier for this test, right? Just find one solution where the sine squared of x is 3/4. We'll start there. So example 2, and again, it will be one of these three, right? So let's go through all three and then we'll be all good. So if we've got the sine squared of x is 3/4, remembering that the squared, right, just behaves like any other square. And so what we can do is we can say, if we're trying to solve for x, right, because that's what we're doing, right? We want to solve the following equations for x. So we're trying to get x on its own. It behaves a little bit differently, right? Because it's an angle. But what we get is if I'm taking the square root, I end up with plus minus the square root of 3/4. Make sure that you've got that plus minus in there. But the procedure for all these three are going to be the same. Right? Notice that the last one is a power of 4, but you could just rewrite that as sine squared squared, right? Do it twice. So then sine x is plus minus the root of 3/4. And so if we've just got 3/4 in there, we can split up the root, right? Because I know that root 4 is 2, right? So it makes it look a little bit easier. And so we've got plus minus the root of 3 over the root of 4, which is just plus minus root 3/2. Now we're working backwards, right? Because now I know that sine, which is the y value on the circle, the y value has to be plus or minus root 3/2. Right. So this is saying y equals plus minus root 3/2. So if we go back to our circle, and maybe I'll steal a fresh one here. Copy.
Oh, so then we just find the y equals root 3/2, and x is just 1/2.
That's exactly right. So let's see here. If we want, we need to find the spot where y is plus or minus root 3/2, right? And so here x is, root 2/2, y is 1/2. Moving on, root 2/2, nope. Root 3/2, cha-ching, right? This would be our first solution, right? That's positive root 3/2. Then we would get to another solution, right? If we keep going here, and then we would get another solution where the y value is there, and then another solution here, right? So we've got all these solutions, right? Plus minus, but And then we could keep going, right? Ding, 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 ding. That's why it says all solutions. We're not there yet.
For each of them.
We only want one solution. So for this one, as soon as you find that first one, you can, right? And so x must be pi over 3.
It doesn't matter if you find the positive one or negative.
No, you can go for, if you prefer to find the negative, if you just go for the first one that you find, that's fine. I always just work in this quadrant. I prefer it, but if you want to find one over here, that's not wrong. That is a solution, right? We're just asking for one solution. And so here, what we're saying is that x must be pi over 3.
Okay, so we don't put the x value, we do the angle.
It gets confusing, right? Because we're taking the sine of x, but x is the angle,
Oh,
right?
so the sine of x is the.
X is the y value. Yeah, so here, this is the angle x. And so here, the angle is pi over 3. So I'll put on the side here, therefore, x must be pi over 3. We'll expand on that later, right? The multiple solutions, but for now, right, we just want one solution. Find the first one that you see on your circle, and that's why definitely have the circle on your cheat sheet, right? You see, like they used to, so this is the formula sheet that they used to give. Ours has more information, but we don't have the unit circle anymore. And so there's another version of it. I like this one because it's sliced up, looks nicer, but they're the same. So just those are for you to copy. Okay. X equals pi over 3 is one solution. And that's all we need for now. So how about we do cos squared x is 1/2. I'll leave the hard one to you. Cos squared x is 1/2. Same idea, right? We're going to take the square root, so we end up with cos x is plus minus the root of 1/2. Same idea, right? I can simplify things a little bit. If I do plus minus the root of 1, which is just 1 over the root of 2. So then I get plus minus 1 over root 2. Cos, remember, is the x value. And what's confusing now is that this is x is the angle, right? So cos is the x value. That's confusing. But if we go here and we need the x value to be plus or minus 1 over root 2. Hey, did I do this wrong? Oh, okay, okay. Egg on my face. I'm not quite done. 1 over root 2, as you saw, when I'm looping around here, hey, there's no 1 over root 2. So what can I do? We can pull some tricks, right? What if I did That feels like a good option, right? Because as I'm scanning that circle, right, I'm seeing root 2 over 2. So what if I can change this to look like root 2 over 2? So then we get plus minus root 2 over root 2 times root 2, which is just 2. And for me, the first time that I see that is at pi over 4. I see it a couple other times, right? But so therefore, x equals pi over 4 is one solution. How about that last one? I'll give you guys a little bit of time to do sine to the power of 4x equals 1 over 16. Just remember that sine to the power of 4 is the same as sine squared squared, right? So you can just do it twice. Or just do root 4 if you want, but I find that's trickier. Maybe it is easier to do the fourth root. As long as you remember to do the fourth root on your calculator, right? You do to the power of 1 over 4. I think that's probably quicker. And we'll see what you do. You're so animated when you work.
That's what my boyfriend does.
Yeah.
So many faces.
I look up and Chloe's like.
Oh no, it must be real.
Yeah, very animated. How about we just go for it? Fourth root. Well, the fourth root, any root of 1 is just 1, right? So we get plus minus the fourth root of 1 over the fourth root of 16. Plus minus 1 over, and then if I, just to make sure on my calculator, right, 16 to the power of 1 divided by 4, and I like to put those in brackets, right? Puts me at 2. But I'll just make a note here that on your calculator, you're going to do 16 to the power of 1 over 4. So now, this is the y value. Now I'm looking for plus or minus 1 over 2. Cha-ching. First stop, pi over 6. Therefore, x equals pi over 6 is one solution. There's multiple solutions. In fact, there's infinite solutions. Technically, right, we could keep going and going and going and going and going around the circle. So we're making it easier and just kind of doing one solution for now. Okay. Any questions about those? So there's going to be one of each of those kind of chunks. Do I have this one here? Okay. So that was section 5.2 and 6.2. this on a new page. Section 5.3. It's going to be one of those that I've listed below. Okay. Any questions about that previous stuff before we do? No? Okay. So what we need to know for this section is that if we've got a curve like, or a XY plane like this, then the graph of cosine starts at 1, kind of goes down. It kind of keeps going and going and going like that. Okay. So this is cosine of x. So it starts at 1, and then this goes to -1. There. Okay. And then we'll talk more about it later, but right, we're going to talk about these cutoff points. So points like here, here, right, here, and here. So we're going to talk about those points, but we'll save those for later because we don't actually need them right now. Okay. Bless you. The graph of sine looks the same, except it starts, right? So it's basically cosine shifted over because it starts at, well, not really, it's going up. It starts going up. Cosine shifted over and flipped, not very helpful. Okay, but the sine curve goes like, and I'm going to try to do the opposite here, where it goes. Okay, I'm doing it. And then it all went to garbage. This is the sine of x. Starts at 0, goes to 1, and then it crosses the x-axis, goes down to -1. Right, so sine and cosine curves. I didn't do a very good job there. I don't know. Good. So far, this all need to know. Okay. How I remember which one starts at 1 and which one starts at 0, right? If I have to list these alphabetically, I'd start with cosine. C comes before S, right? Cosine, sine. I don't know if that, but that's how I have to, because we have to remember which one starts at 1 and which one starts at 0, right? And so I just alphabetize them and say cosine, sine. Okay, so there's a couple of things, so some terminology that we need. Terminology for graphs of sine and cosine. Of sine and cosine. First thing is the amplitude. The amplitude, oh yeah, so it's confusing a little bit because when we write sine as a word, it has an E on the end, right? And so does cosine, so cosine, sine. But But if we're just using it as a function, then there's no e. So the amplitude is going to be the distance from the x-axis to the peak, wherever the peak is. So the amplitude is the distance from the x-axis to the peak. The period is going to be how long does it take, so what distance of x does it take until the curve repeats itself, right? We know sine and cosine look like this and they keep going forever and ever, right? And so for cosine, for example, we started up here and then we're back up there, right? So this distance would be the period. And same thing for sine, right? We start down here, right? And so this distance would be the period, right? So the period, is the distance of x, right, needed to cover one cycle. The distance of x needed to cover one cycle of the graph. So if we're going to draw these on here, right, for both of these curves, this distance here, oops, that's the period. And this distance here is the amplitude. Oops. If they're not starting on the y-axis, right, the phase shift is going to be how much it's shifted right or left. And so finally, the phase shift, can also be called the horizontal shift. That's the distance moved from the original location. Okay. So it's the distance of x moved from the original location. And by that, I mean the y-axis, right? They're all starting from the y-axis, right? Cosine's up here, sine's down here. So if you go to the formula sheet that you will have on the test, on the second page down at the bottom, you've got kind of cryptic looking stuff, right? But let me see if I can pull it in here. Oops. Hey, where did I? I guess I will just grab it. Question is, where did I put it? Okay, maybe we'll just write them out. Sorry, I don't have them. I thought I did. So depending on if we've got y equals a sine of b times x minus c, and this is just plus d. Or if you've got a cosine, it behaves the same way. So let's just focus on the sine one. And then I'll just say cos behaves the same way. So we'll just focus on this one. So what it says is that, okay, if you've got the absolute value of A, that's going to be your amplitude. I'll rewrite it like this. The amplitude is the absolute value of A. So let's go through each of those ones that we've been given. Oh, and Jenna told me it's not going to be 37. So it's not 37. Just because it's got multiple things going on. But we can still talk about what the amplitude is for each of these, right? And so for 33, the amplitude is 1, right? Just going to be a height of 1 from the x-axis. For 34, the amplitude is 2. For 35, the amplitude is also 2, right? Because we have to take the absolute value. And then for 36, it's going to be 3. And for 38, well, let's do 37, right? Be 4. And then for 38, it would be back to 1. So for all of these, and I guess I can bring them in here. Let's do like this. So here, A is 3, or the absolute value of A is 3. Here, the absolute value of A is 2. Oh, it's not. Thank you. I don't know what I was looking at even.
36.
Maybe, probably not though. So the absolute value of A is 2 for 35, and then the absolute value of A is 4 for 37. So what we'll have is we'll be given, well, one of these, but not 37. You'll be given one of these, and then you'll be asked, okay, what's the question say? Find the amplitude, which we've done, right? The amplitude for each of these is, the absolute value of A is 2, the absolute value of A is 3, and here the absolute value of A is 1. So we've been able to find the amplitude of each of these. Then we're going to find the period. So if you go back to your formula sheet, it says that the period is called t, which we don't really care about, but it's 2 pi over the absolute value of b. And what we decided to do is, instead of having you graph it, we'll just give you 4 options for the graph and you just pick the right one, just like on WebAssign you've been doing, right? And so so as long as you're able to figure out, okay, what's my period, what's my phase shift, what's my amplitude, you'll be able to pick out the right graph, right? And then you just circle it or something. Okay. So the period is 2 pi over the absolute value of b, where b is coming from the general setup, right? And so if b is 1, then the period is just going to be 2 pi, right? So the default is going to be just 2 pi for our period, which makes sense, right? If we're going through a whole circle, because what the sine and cosine curves are doing, they're just cyclical, right? Ding, 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 ding. Right? And so if B is 1, right, the period is 2 pi. Okay? A little bit trickier if we don't have B as 1. So let's just have a look through each of these. So 33, 34, 35, 36, 37, and 38. B in 33 is just 1. Same thing with 34, same thing with 35, same thing with 36, right? Not for 37 and not for 38. Right? So for all these, B is just 1, B is 1, B is 1, B is 1. For 37, let's have a look. B is 2, right? And then for 38, B is 1/2. What's important though is B is not your period, right? 2 pi over the absolute value of B is your period. And so here, right, if B is 1, then we've got a period of 2 pi. Right? And I'll just do ditto signs all along here because I'm lazy. Right? It's going to be the same. Here, the period is 2 pi over the absolute value of 2, which is going to be 2 pi over 2. Oh, not 2, but pi. So now my period is pi. What does that mean? That means my graph is going to be squished together, right? Because now instead of having 2 pi distance to go, now I do a whole cycle in just pi. Right? And so what I'll say here is that the graph will be squished, right? Using the very technical terms of squished and stretched. Squished, stretched. So now, if B is 1/2 instead, then my period is 2 pi over 1/2. It's the absolute value, but I can kind of ignore it. 2 pi over 1/2, I can treat that as a fraction over a fraction, right? And so I get 2 pi over 1 times 2 over 1. Puts me at 4 pi. Right? So instead of the usual 2 pi, now I've got a stretched out 4 pi to cover the whole cycle. And so here, this graph will be stretched. So those are things that you're looking for. If we're trying to pick a graph, right? Sorry, I guess I didn't talk about the amplitude. The amplitude, right, is the distance from X to the peak, right? And so if you've got an amplitude of 1, that's the default. But then if you've got an amplitude of 2, right, then it's going to be stretched this way, right? So then it just has a higher amplitude. So find the amplitude, the period, and horizontal phase shift, or the horizontal shift of the function. We're calling this a phase shift on the formula sheet. And so I asked Jenna if we could just use the term phase shift in the question instead. So just make sure that you are okay with using either. This is the phase shift. Horizontal works too, but right, we know C is the phase shift. You've got it in front of you, but I'm just going to copy it down so that I have it. C is the phase shift. The phase shift is how much it's been shifted, right, off of the original. So if you get a phase shift of 1, it means everything's been moved over, and we are using the positive. So if it's positive, it's moving in the positive direction. If it's negative, it's moving in the negative direction. Notice that we've got x minus c in our core function here. And so if we talk about copy, if we talk about the c in each of these, right? If I'm trying to match my function and the cosine one looks the same, so it doesn't actually matter. So here, my c for 33, so for 33, c is 1 or pi over 2, right? Because it's x minus c, x minus pi over 2, so c must be pi over 2. For 35, c must be pi over 6.
So it's not negative pi over 6? It's just
No, yeah, that's the confusing part. Because it's got that negative built in. So in fact, if we get a positive, then our c is negative. So that's when we move to the left. Right? And so for 37, if I'm just working down, doesn't matter which order we do them, then c must be negative pi over 2. And then for 34, c must be pi over 3. For 36, c must be negative pi over 4. And for 38, c must be negative pi over 4. The negatives are to the left, right? So we shift to the left in the negative direction, and the positives are to the right. So you'll have to do one of those, but like I said, we'll give you 4 options for the graphs, and then you just pick the right one, right? Based off of, but you do have to show me that you know how to find the amplitude, the period, and the phase shift. Right? But those are on your formula sheet. Right? But if you like to have them in your own handwriting so you know where it is, that works too. Any questions about that one before we keep going? Oh. We're doing it. You're doing so well, guys. Okay. Inverse trig functions. I actually think a lot of you will have this on your calculator, so it's not, hopefully it's okay, but that's all right if you don't. That's more to double check your work anyways. So this is from section 6.4. there's 2 questions from 6.4. And so here's the first question. It's going to be one of these. And then there's the second set of, or block of questions. There's going to be one of those. You're getting like, whew. Okay, inverse trig. Here we go. If we have, so here's what we need to know. If we have sine x equals y, then what we know is that, okay, well, I can do the sine inverse, and we haven't talked about that, but that's what we will do. So the sine to the -1 is a sine inverse, which is essentially how we're going to move this sine over to the right-hand side. So what this is saying is that x is going to be the sine inverse of y. Okay. And if you are using your calculator, you'll want to make sure that you're in radian mode, right? None of these questions have degrees, so you'll want to be in radians. And if you don't know how to change it to radian mode, just let me know and I'll show you. Or we'll figure it out at least. Okay. So, let's start. Oh, you know what? There was a shortcut for this one. It's not on your formula sheet, so it might be another thing that you want to have on your cheat sheet. But if I bring in this formula sheet, so we can use the special triangles. We'll deal with those later, just because, so we will use those special triangles that are up above there, but for now, no thanks. Right, I'll say put this on your cheat sheet, right, along with whatever unit circle you like. Because this is how we're going to be able to do these things quickly. So for all of these problems, right, I'm asking what value can I feed sine to give 1? So if I want a sine of 1, so here, right, I'm just looking at 5a. So the sine inverse of 1 is saying, okay, well, when I take the sine of something, it gives me 1, right? Those are equivalent. And so what I want is, okay, well, I need sine then to be 1. That happens if I give it an angle of pi/2. Right? We're ignoring the degrees. We're only working in radians. Okay? And so how you're going to do these, right? Sine inverse of 1, sine gives me 1 if I'm at pi/2. Right? And so here, 5a, sine inverse of 1 is pi/2. How about 5b, cos inverse of 0? Same thing, right? I start at cos and I find 0. There's actually 2 options, right? Pi/2 or 3 pi/2. I'm just going to go for pi/2. Started with the quick and easy ones. Tan inverse of √3. Looks bad, but with the table, right? I'm in my tan column. I'm finding a root 3, not root 3 over 3, just root 3. Is that pi over 3? What if we do something that looks a little harder, right, but probably isn't? Yeah, do you want to do 7 or even 8? Doesn't matter. Let's do 8a, and maybe I have sine inverse of negative root 3 over 2. This one's trickier, right? Because I know the angle must be from here, right? I know my angle, so if I'm taking sine root 3 over 2, my angle must be pi over 3, right? But I need that to be negative, so I'll make a little note here. Angle is pi over 3, right? That much we're okay with. And so what we want to do is we have to figure out where the sign is going to be negative, right? Negative sine pi over, or I guess, heck, why not? Use that unit circle maybe. Maybe that'll point us in the right direction. Yes. Yeah. And it works because I'm seeing 5 pi over 3, right? So let's just do that. Maybe you only need the circle. Maybe they're all just telling me the same thing. They are, but just kind of different for different occasions. When you do go to check the solutions for this one though, and for some of these, it's not going to match, but it's okay, right? Because because I'm just kind of warning you here, because on the solutions it says negative pi over 3, but our solution of 5 pi over 3 is the same as negative pi over 3, right? Negative is going in the clockwise direction. 5 pi over 3, we're just coming at it the other way. And so it puts you in the same position. And so here, maybe what I'll do instead is say, using unit circle, we found that this is equal to, what did we find? 5 pi over 3. In solutions, it says it's equal to negative pi over 3, right? But that's just the same thing. But these are equivalent. Oops. So I'll let you guys work on those because on your own, because I want to do the very last question, then we'll have talked about them all, and I will be around if you have questions. So it's not the end, it's just the end for now. The reason that I wanted to talk to you about is because the solutions for 30 and 32 are a little bit wonky. So I checked with Jenna. I was like, hey, am I going crazy or what? She's like, no, those are wrong actually, but they're from the textbook, so I don't know what happened. Question.
4 by 3 upon 4 pi upon 3 is also the answer of this question. A, according to the circle.
For question A, let's see here. Oh, I'm looking at the wrong place.
No, A3.
Wait,
This one.
this one?
Yeah.
Right? The sine inverse, yeah, because y is going to be negative in 2 spots. Yeah, so it's okay. Let's do the next one. All right. What we do here for all of these, is we say that, okay, the sine inverse, so looking at 29, we've got the cos of sine inverse of 4/5. Temporarily, let theta is just our default angle representation, theta be sine inverse of 4/5. This one's not on the circle, but it's okay, right? Because what this is saying is that sine theta, because, right, the sine inverse of 4/5 means that sine theta must be 4/5. Right? And so what we can say is that we've got sine theta is 4/5. Okay. This is where SOHCAHTOA comes in. SOHCAHTOA. Sine is opposite over hypotenuse, right? And so here, this is opposite over hypotenuse. So what I'm going to do is I'm going to draw some triangle, as long as it's a right triangle, right, with a 90-degree angle in there. Doesn't really matter which corner I put theta in. Just put it down there. So if the opposite is 4, and the hypotenuse is 5, we can use the Pythagorean theorem that says that if we have some sort of, and I'm pretty sure this is on your formula sheet for whatever reason. It is, right? So it's on the one that you're given. But you've got A, B, C, well then A squared plus B squared equals C squared. Right? So then we're able to solve for this one, if we need it, which we probably will.
So it's 3 then. Is 3 the answer of the sine of theta?
Yes. Is it 3 squared plus 4 squared is 5 squared? Yeah.
I think so.
So here, right, we've got 4 squared plus, and then we can call this b squared is 5 squared. So b squared is 25 minus 16. Pardon? Oh, it's okay. I shouldn't have done that, but it is allowed. I'm just calling this A, or sorry, I'm just calling this B, but because the short sides, it actually doesn't matter.
Okay.
The C has to be the hypotenuse, but the A's and the B's don't matter. But you're absolutely right. I shouldn't be doing that. I should be calling this A. So then I get A squared. Oh, A squared plus 4 squared is 5 squared. So A squared is 25 minus 16. So A squared is 9, which means A must be 3. Nice. So A is 3 from down here. So now we know, right, that this theta, we know what triangle this theta is in. And so what we want to do, right, is remember that, okay, well, this theta is what we said this whole thing is. So now I just want to take the cosine of this. But the cosine is the adjacent over the hypotenuse, right? So ka toa. And so the adjacent over hypotenuse puts me at 3/5. So, So then recall that we have the cosine of sine inverse 4/5, which is the same thing as the cosine of theta. And the cosine of theta is adjacent over hypotenuse. And that's actually on your formula sheet as well, right? They don't call it SOHCAHTOA, but they're all on there. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, which means you've got your adjacent side, which is 3 over the hypotenuse, which is 5. So that one's like multi-step, right? But it's definitely not as bad as it looks when you first have a glance. So let's do 30 together, just because there is that typo in the solutions. So there are typos in the solutions for number 30 and 32. So let's do 30 together. And I know I'm out of time, and if you have to go, it's okay. But I think it'd be good to just do 30 just so you see what the typo is. Right? And then maybe you can find the typo in 32. How about that? So 30 is the cosine of tan inverse of 4/3. So we want the cosine of tan inverse of 4/3. Oops. Same step as before, right? I'm going to let theta be tan inverse 4/3, which means tan theta is 4/3. I'm just kind of moving it over so it looks better and what we're used to. Tan theta, opposite over adjacent. Right? So here we're opposite over adjacent. So again, I just draw kind of any triangle, any right triangle And usually it doesn't matter the lengths of the sides. Usually I'll just put theta down here. Because now the opposite is 3. It's the same triangle. They're not very creative, but we're just arriving at it differently. So yeah, so it will be the same triangle.
Yeah, and it's also both cosine of 3/5.
But the adjacent side of 3, we drive right in with the opposite side 4. Oh, did I? 4/3. Oh, I see. In the solutions, if you're looking at the solutions, maybe I don't know, practice the solutions. They'll be at the very end here. This is the typo. It's not an error in the solutions. I was just going off of what was on here, right? And we actually want just 4/3 there, not 4/5. So that's the error, because then I was looking at this and I was like, oh, that's not right. Same thing with 32, but okay, good. We figured it out. So then we know that this is going to be 5, right? Because we just saw this thing. And then if we want the cosine of theta, it's the adjacent over hypotenuse. So cos of theta is the adjacent over 3. I'll have to check 32. Make sure, see what the error was, but that's the right answer for that one. And it's not going to be 32. How about that? Any questions? I bombarded you. Oh, shoot. Can we do my evaluations? Do you have time?
I think so. No,
Are they waiting? They can wait. Can we just do them so I don't have to think about these anymore? Have you guys done them before? Okay, so so here, these ones, they're though fun for me to read. I get them in the summertime sometime. They're just comments to me, so no one reads these except for me, which I was kind of disappointed about when I was a student when I found that out. But these ones are the ones I care about, and they're just bubble sheets. Okay? So it's just one page, and it's just how the college keeps track of how I'm doing. If I'm doing a good job or a bad job or just so-so job. Okay? And so if you don't mind doing these, just quickly, like I said, these ones are the important ones. I'll hand them out. You can only handle pen. So if you don't have a pen, I can lend you one. But if we can get these done, that would be awesome. Okay. So then, what I'll do when you're done with those, you'll just go in this envelope because I'm not supposed to see them, so I won't come. You can just stick them in here. I'll put this in the back. Yeah.
Can you just extend the
Oh, yeah, if you guys want more time for the quizzes, I can definitely move those due dates. You can use them to practice, but then it's less stressful.
Yeah.
Which ones? Just the 5 and 6?
Yeah.
I can move them all. It doesn't really matter to me.
I mean, I wouldn't be upset if you moved them all.
Cool. How about I move them all? I give you guys more time. You can use them to study if you want to, but then you don't have to.
So it will from third onwards.
Honestly, I was just trying to get them done before the quiz so that you would practice. I can just make them due at the end of the term if you want. Do you want that?
No.
No? Well, how about you can set a personal due date for yourself?
End of this month. No,
Yeah, maybe March. How about the end of March? Because then you'll know your assignment grades. Yeah. And then if you want to do a comment sheet, you can grab one.
I can